So here we're gonna look at example 6 in the handout, and it has two sub-questions. Using a reference angle, find the exact value of cosine 150 and sine 150 degrees, and using the reference angle, find cosine of 5 pi over 4 and the sine of 5 pi over 4. So let's do one at a time. We're gonna start with the first one. Here's my unit circle, and 150, it's actually 30 degrees shy of 180. So I already know what my reference angle is going to be, 30. Okay, so it is, but let's draw a picture. It's in the second quadrant. Right here, it's 150. So this piece right here is actually 180 minus 150. So it's going to be a 30-degree angle. Now, in order to figure out the x and y coordinates of this angle, we're going to look at a symmetric angle in the first quadrant right here. So this is going to be our reference angle. And we know from previous videos that the x and y coordinates of this point for 30-degree angle would be square root of 3 over 2 and 1/2. Okay, so what that means is, well, but we need to find the cosine of 150 degrees. So cosine is the x coordinate, and we know that in a second quadrant, it's the x coordinate is negative, so it's going to be the opposite of cosine of 30 degrees. So which is square root of 3 over 2, so it's going to be negative root of 3 over 2. For sine of 150, in the second degree, both y coordinates are positive, so it's going to be the same as the sine of 30, and that equals to 1/2. Okay, so that's question A. Let's move on to question B. So for question B, we have 5 pi over 4. Well, it's if I had 4 pi over 4, that would be exactly pi. And this is 1/4 more than pi. So it's this angle is in the third quadrant, and pi over 4 would be its reference angle right here. Okay, so this angle is right here. This is 5 pi over 4. All right, and the reference angle is right here, or this one right here. It's the same. Okay, so how do we find it? We take 5 pi over 4 and we subtract pi from it. So we turn it in pi into a fraction for pi over 4, and we're left with 1 pi over 4, or just pi over 4. So this angle right here is pi over 4, and we know that that's a 45-degree angle, and the x and y coordinates are square root of 2 over 2 and square root of 2 over 2. All right. In the third quadrant, both x and y are negative, so these will change. I'm going to write here. It's a negative square root of a 2 over 2 and a negative square root of 2 over 2 again. So the sine of 5 pi over 4 is going to be the opposite or negative sine of just pi over 4. So it's going to be negative square root of 2 over 2. Same goes for cosine. So negative root of 2 over 2. So that's how you can figure out the function values in different quadrants. Now I want you to try it yourself, and here's the problem that I want you to solve. Use the reference angle of 315 degrees to find cosine of 315 degrees and sine of 315 degrees. And the same thing for negative pi over 6. All right, go ahead and try it. And I assume that you did, that you paused the video and solved this problem by yourself. If not, let me know. And the last example that I want to do in this section is this. It says using the unit circle to find coordinates. Find coordinates of the point on the unit circle at an angle of 7 pi over 6. So again, just by looking at this algebraically, we know that it's 6 pi over 6 plus 1 pi over 6, right? That will give us 7 pi over 6. So it's, and 6 pi over 6 is just pi. So it's basically pi plus pi over 6, right? So looking at the unit circle, and you could just eyeball it too, just looking at 7 pi over 6 is a little more than a pi. So it's pi over 6 more. Okay, so this angle right here, this is 7 pi over 6. And the reference angle right here, if we put it in the first quadrant, so we know that this is pi over 6, right? It's this. So it's pi plus pi over 6. So pi is right here. This is pi over 6. And so this angle here is pi over 6. Do we know the coordinates? And the answer is yes, we do. So the coordinates here are square root of 3 over 2 and 1/2, same as for 30 degrees. And then the coordinates of this point on the other side of the origin, symmetrical with respect to the origin. This is negative root of 3 over 2 and the negative 1/2. All right, so I would like you to try by yourself, and here's the problem. Find the coordinates of the point on the unit circle at an angle of 5 pi over 3. Again, go ahead, pause here, and Okay, I assume that you tried this problem, and I want to go back to example 6, and I want to finish finding the rest of the trigonometric functions um, of all of these angles, because you will be asked to do that sometimes. Okay, so let's find the tangent of 150. So tangent of 150, the definition is it's y over x, right? Y over x. Well, we know that on the unit circle, sine is same as y. So we have 1/2 divided, and the cosine is the same as an x. So negative square root over 2. Now we have a fraction divided by fraction. How do we divide fractions? It's the first one, and then division turns into multiplication, and we flip the fraction. So 2 goes on the top, and negative root of 3 is on the bottom. And then 2 and 2 are canceled out, and we're left with 1 over the negative root of 3. But we need to rationalize denominator, and I don't like the negative in the denominator. I could pull it in the numerator. That's the properties of fractions. It's up to you where you want to put your negative sign. You could actually have it in the denominator, move it into the numerator, which we're going to do, or leave it in front of the fraction. Same thing. So rationalizing the denominator, we'll multiply both the top and the bottom by square root of 3. That gives us negative root of 3 divided by 3. So that's our tangent value. And I'm going to use a blank piece of paper here to continue. Okay, so that's the tangent. Now, secant of 150 is going to be 1 divided by cosine of 150, or just the flip of cosine, right? So we have the cosine of, it's actually 1 divided by negative square root of 3 over 2. But that just means just take it and flip it. So minus 2 root of 3. Same thing about rationalizing the denominator. So the secant becomes negative 2 roots of 3 over 3. So even though it does not actually look like exact flip of the cosine, in reality it is, even though it looks slightly different. Okay, so next, cosecant. Cosecant of 150 is 1 over sine. So this is going to be 1 divided by 1/2. So again, it's a flip, 2 over 1. So that's just 2. That's the cosecant. Now, what about cotangent? Again, it's a flip. It's x over y, and it's just a flip of what we have for the tangent. So for the tangent, we had so it's 1 over negative root of 3 over 3. And actually, what I'm gonna do, okay, I will hold this thought for later. So it's 1 times -3 over root of 3. So what I need to do now, I need to rationalize the denominator, multiply by root of 3 and the root of 3, which will give me it will give me -3 root of 3 divided by 3, and then I have to cancel 3's, and that will give me negative root of 3 over 1, or just negative root of 3. But look, if I took this intermediate result before I rationalized my denominator and flipped that, I would get immediately, I would get root of 3 divided by -1, which is negative root of 3, which is what I got. So sometimes these intermediate results are very useful when you're looking for the cofunctions. And that's how you find all the rest of trig functions if you know sine and cosine of an angle. Okay, and then when you know only sine or only cosine, you can use Pythagorean identity to find the other one. The only thing you need to know is which quadrant your angle is in, because you remember you have to select whether a positive or a negative value for the square root when you're solving this identity. So here it is. And let me know if you have any questions.